Filled with hours of J.
All right, we are live. All right, welcome everyone. Hopefully, we have a few people sitting on the channel. If not, this is being recorded for posterity. This is the first episode of the OpenStack Bootstrapping Hour. Um, we'll do kind of a round of introductions and then we'll get rolling. As this is the first time that we're doing this, assume that we're going to have all sorts of snafus along the way. Bear with us. We're working out the kinks in the technology, but hopefully you'll all find this useful. So I'm Sean Daig. I hack on a bunch of stuff in OpenStack, Nova, infrastructure, QA. Let's flip over to Jay.
Hey, I'm Jay Pipes. I work on Nova and kind of been around the OpenStack community for a while. This is Winnie. Hi, Winnie.
Hey,
Uh,
Winnie.
uh, yeah, I'm kind of jazzed about doing this bootstrapping hour with Sean and Dan. So
And Dan.
Yeah, I'm Dan Smith. My IRC nick is Dan Smith. I work on Nova mostly, and my head is really oddly shaped like a slide deck, but no one can see it.
Dan is playing the role of the slide deck today. All right, so today the first thing that the topic for today is talking about mock best practices. I'm going to turn things over to Jay to actually get us rolling here, and we'll look at the slides. We'll look at some code examples. We're going to be following along in the Etherpad as we go as well. So please follow along with us there, and we're going to take questions off the Etherpad once we get later on in the program. So
yeah,
Jay, the floor is yours.
at the bottom of the Etherpad, there's sort of like a notes section and a question section. So as we go through these topics and stuff, just start talking. If you have questions, just list them there, and we'll address them as we can. So
Yep. We got 18 people on Etherpad, so we got some people engaged at the moment.
yeah. So so I threw together some slides today. Just not like we are sort of pontificating about the way you should do things, but more just as sparks for discussion and sort of topic areas around things that we've run into with the mock unit test library and what works and what's sort of confusing, what people run into a lot of times. And so a lot of these slides are just sort of examples of how to do certain things with mock and how not to do certain things with mock. So Dan, could you go to the first slide thing, please, Mr. Dan?
I did. Can you see it now?
Yeah, I think there's a slight delay on the slide flip.
Oh.
I will try to anticipate then. But yeah,
All right,
I've
well,
switched it.
I can't see it, so I'll just flip to the other way. So, so from the Etherpad, I kind of grabbed a gist of that. There are some disagreements about sort of what is a good unit test and what a unit test should cover. Right, and I have some fairly strong opinions on this. Dan and Sean certainly do. Matt Riedemann and Matthew Booth and lots of other folks clearly have lots of opinions here. So I guess I'll just kind of start off this discussion just saying that to me, a good unit test is as small and explicit as you can possibly make it. So when you're testing a specific interface, either a method or the way a set of object attributes or calls work with each other, if you can structure the unit test so that it is very explicit about what it's trying to assert, as well as covering a small surface area in the code, I think that's the best way to structure unit. So a good test unit is sort of like a small test unit. And when you see a unit test that goes on for pages and pages and pages, or that has so many assertions for so many different things, it's generally a sign that the code that the unit test is attempting to test is pretty crappy. and sort of has a lot of assumptions in it, or sort of bad practices as far as code structure. Would you guys agree with that, or is there things that you'd like to add to sort of like the discussion of what is a good unit to test? Like how do you identify what to put into a specific unit test method?
Yeah, I think I'm fine with that sort of definition of small scope is good. Build solid blocks on the way up to a complex thing.
Right. And be explicit about what you're testing. Try not to make any assumptions about the calling code. Another thing that I didn't put in here that's I think is important to mention is when you're doing unit tests, especially on logical, sort of conditionals within the code, a lot of times you're tempted to just cover one of the conditions. So if you have, I know there's no case construct in Python, but you can sort of emulate it with using a dict lookup. But a lot of times you'll see unit tests that only traverse a single choice in that conditional, and it's sometimes difficult to take a look at a piece of code, a specific method that you're trying to test, and really know that you have 100% coverage of all the things that could happen within that that method or that function. And a lot of times the reason that you're not going to get 100% coverage is because of all the conditionals that all the branches, the code branches that can happen but aren't obvious. They're not necessarily if-else blocks. They are lookups into a function, or they're sort of case or if-else blocks of things that are driven by return of another function or method. So anyway, Dan, if you can move to the next slide here, I kind of just sort of threw a dart at some of like the worst examples of unit tests. Well, they're not really unit tests, but this is just one of them, and it's like 168 something lines, and it's just impossible to follow, right? We've got hundreds and hundreds of examples of these kind of things in the Nova unit tests, and I don't really see much of a value to these kind of things being unit tests. I think a lot of times they are more functional tests, and by attempting to write these kind of things as unit tests, we end up mocking or faking out so much stuff that it's impossible to take a look at the test and clearly identify what exactly it is trying to assert. And when I was talking to Dan earlier today, he said, if there's a couple screens of code that you have to scroll through in order to determine assumptions or conditions or what a mocked object is, you're kind of missing the point of good practice unit test writing. And you have to seriously consider whether you need to break that test method out into multiple test methods, or seriously consider refactoring the code on which you are trying to test. So a lot of this large unity tests are because they are testing a code path all the way through, say, the Nova compute worker or the Nova API and into all sorts of dependent services. And if you're writing unit tests for that level of going through lots and lots of different dependencies, I think you're kind of missing the point as to what a unit of code that should be in a unit test.
So not just that, but there's certainly the possibility to have code that's in the tree that is so big and bloated that writing even a real unit test for that thing becomes an enormous task. And certain maybe alternative network API modules that we might or might not have in the tree are particularly bad about this. So it's not just that the test scope might be too large, but that maybe the function or the method that we're trying to test in Nova needs to be seriously broken up in order to test it properly, instead of being a 300-line method itself.
Right. I think another thing that I touched on this bottom bullet point is whenever you use faked methods, and I'm not talking about using mock to mock out a method, but actually writing a fake method and then setting that as your fake get method or do something method, you're adding a surface area, an additional surface area where you can make mistakes. So there's a ton of examples in the code where you'll see fake this or fake that, and you'll be using stub out to set a real method to this fake method. Well, now what you've done is, instead of validating that the call signature to a method or a function that the unit of code you're testing is looking a certain way, now you've added a whole new surface area that can have mistakes. A lot of times you'll now be unit testing your fake method and not really adding any value to the test coverage of the real code. A lot of things that I've seen in the testing of the image service had issues with the fake image service having a certain call signature that didn't relate or didn't match the real one. And so the unit tests would succeed because the code was testing the fake method, and the fake method's call signature was not keeping pace with changes to the real image service call signatures. And so the unit tests would just happily pass everything because they were correct. They were succeeding by calling the wrong faked method. And so the more you fake out things and test only the fake call signatures, the larger the possibility of making mistakes, and mistakes that tend to stick around in the test code base a long time because no one really notices. So that's why I think it's really important to only mock out the specific method in the real code while you're doing unit tests, and then verify the call signature is exactly what you expect in the real code, and not use fake methods to do stub out calls.
So, so do we want to jump ahead a couple slides to where like the examples of what those patterns are in mock? Because I feel like it becomes a little more concrete if we can kind of see some of those. I think that's like, where do we start on that? Like slide 5's got the first example, I think.
Yeah. So this is an example of what I think is a good example of testing a very small surface. And it comes from the newly refactored unit tests of the Glance module, the image API module.
Is there a GitHub link as well to this that's in the Etherpad somewhere?
I can paste it in a second here.
Okay, just because I think so. For the live screen, the text is a little hard to read.
Yeah, I'll paste it in here. Cool. Sean, go ahead and talk about this, and I'll paste the link. I'll grab it.
Well, I thought Dan was talking.
Oh, Dan doesn't talk.
Yeah, this is Jay's example. I don't know anything about this stuff.
All right, 1 second.
Plus, it's Jay that didn't put the GitHub link in there, so I'd rather him be the awkward rushing pasting.
All right, where should I put it? How about?
You put it in the show notes at the bottom or wherever. Doesn't matter. We had someone post earlier that it was like a little hard to read some of the text, so I want to make sure we have links for
There you go.
folks watching along.
Slide 5. All right. So the code in slide 5 comes from that code page, test code page. It's testing a method in the nova.image.glance module called getRemoteImageService. And although I'm not a huge fan of this particular method, the point of showing this particular piece of code is that it's only the whole class, the test class, test_get_image_service class, is only testing a single method, and the test methods within that class are testing the specific code paths within that method. So this glance get remote image service method does two things. One, if you pass it an image ID, like a UUID or a URI, it will figure out whether what you've passed to it is an ID or a URI, and it will return a glance image service object along with the ID, the image ID, not the URI. And that's all it does. It's not the greatest of designs, but that's the only things it does. And these two test methods, get remote image service from ID and get remote image service from href, tests the two code paths that particular method, glance.getRemoteImageService, can go down. Very importantly, and the reason this is actually different from what these tests used to look like, is that we are mocking out the call to glance client wrapper.init. And the reason is because we test the constructor of the glance client wrapper in other places in this test file. We don't want to mix up testing of the client wrapper constructor with the testing of get remote image service. And that's why we mock out the call to the constructor of glance client wrapper. And we don't care about what it returns because we have tests that test that stuff. All we're concerned about for this is the logic within get remote image service. And so for both of these test methods, we mock out the constructor of glance client wrapper. And you'll see that there's an underscore ignored argument, and I don't know if you if this is common practice or whether this is actually in the hacking guidelines, but when you construct a variable that you do not use, where you're basically ignoring the returned value, you sort of preface it with an underscore. Sean, I don't know if this is in the hacking guidelines or not, but I think it might be for the regular code, but not for the test code. So in this case, what is returned from get remote image service is the client object that you can then use to do things, and the image ID. In this case, we don't care about what is returned, right, the client object, because we have tests or the client constructor elsewhere. And all we're concerned about is whether the returned image ID is correct, whether we pass in a URI or a UUID or an ID-like object. And so this was my example of like something that has a very small test surface and doesn't go outside of that test surface, trying to figure out, for instance, if we did not patch glance client wrapper.init here, then we'd be mixing in a test of what the glance client wrapper does with a test of what get remote image service does, and that's a no-no. We want to keep the test surface area small and specific to that method that we're testing in this class.
So let me just maybe reiterate or just walk through and make sure all the mechanics are here. Yeah. So the patch is just stubbing out that init method on the object with some magical return value, which is like nada. So whenever that object would show up, we just get a none Or we get a mock object.
We get a mock object that gets passed to the test method.
Yep.
And then
at the end of each of these, we're actually just making sure that that assert called once with just ensures that, yep, we did an init call somewhere in this path.
And we supplied these arguments to it, but we don't care what happened in. We only care that the client was instantiated with these arguments. We don't care about anything else that may happen in the real client constructor.
Okay, so this is a pretty good instance of, we did this thing, and one layer below, that thing caused something else to happen. We just want to make sure that the one layer below,
exactly
like we thought.
I'm actually going to post a link here to the actual code that this is testing.
Okay.
So right here, it's right here.
And I guess the only other question about this is that in here there's this, mock sentinel context thing, which there's nothing else sort of within at least the scope you can see about what that is. Like, what is that?
I think he's got a slide. Don't you have a slide later about sentinels?
I
Okay.
do about sentinels.
So why don't we just jump forward to whatever the next example is, then we can come back to it.
Okay. So what I did in the show notes here, I added a link to the very specific block of code that is testing, so that you can compare it and say, okay, now I can see why they don't care about, for instance, what happens in the client constructor. They just care about what arguments are being passed to the client constructor. So
cool.
So the next several are the different styles, both right and wrong, for mocking things out, right?
Mm-hmm.
So this is the first one. It's a good example of a horrible way to do it.
Which were we looking at? Is this the context lib one?
Context lib.nested, yes.
Okay, so slide 7 for people following along at home.
Right.
And I just posted the thing in the Etherpad. Yeah, there's a lot of things.
So that's like an extremely common technique that you'll see. There are two, I guess it's alternatives here when you need to patch a number of things. I suppose we could also have put in the use of mock.patch.object in nested with statements without the use of context-lib.nested. It's worse.
Okay.
But this is one way of doing it. It's using the context-lib.nested
Abomination. Oh, sorry.
context manager to mock multiple objects and returns a tuple of mocks that are then called with assertions once flavor.save is executed. So if we walk through this, the purpose of this test is to ensure that the database API methods, flavor extra specs update or create, flavor access add, and flavor access remove, are called with specific arguments when flavor.save is called. So with context-lib.nested, and then there's 3 mock.patch.object calls in there that return a tuple of 3 mocks: extra specs update, access add, and access remove. And then you do the flavor save, and then you assert called once with for each of those mocks to determine that in the course of doing flavor.save, that those 3 database API calls are made with specific arguments.
And for anyone that's not familiar with the way this contexting works for mock, the thing that you've patched out, that you've mocked, is only mocked for the duration that you're in this context. So when you return back to the nesting level that the width is at, the thing is no longer mocked. So it's not mocked above, and it wouldn't be mocked below this context. So it's actually a nice way to only mock something out in a very small scope, which is awesome. But if you need to do several things like this, it just gets way too ugly.
Correct.
So given that this is given as an anti-pattern of don't do it this way, like what in your expert opinion, what would be the right way to
Well,
tear apart this thing?
so if you go to the next slide, we have the alternative example.
Okay.
And the best part about this particular example is that this is from the exact same test file.
Okay.
And in fact, Dan wrote the one that you see on the screen here.
I don't think so.
Well, let's just assume Dan did. I didn't say which Dan, right? There's a number.
There's a lot of Dans.
Anyway, so this specific example is directly above the other one, the one from the previous slide. So it just goes to show you that multiple ways of doing the same thing have been allowed into our test suite, probably because I think there's differing opinions as to what is stylistically nicer and what is more common or more readable and that kind of thing. Anyway, this is an example of doing virtually the same thing, but with the mock.patch.multiple context manager. So the mock.patch.multiple context manager, instead of returning a tuple of mocks, it instead returns a dictionary of mock objects where the keys of the dictionary are the keyword arguments given to mock.patch.multiple. So
if I did write this might have been early on in our conversion over to mock before we got a lot of kind of patterns going. I don't see this used all that much in the Nova code base that I can recall. Part of it.
Do you prefer this over contextlib.nested?
Well, I think this looks better to me, but the thing is, this doesn't work if you need to patch like 2 or 3 things in different places, right?
That's correct. So here it's working only because DB has 3 different methods mocked in it. It would not work if we were mocking DB and objects and something else, right?
Yeah. So my preferred way over either of these two is with decorators, either on the main test method or on a sub method that we created to actually do the work, purely because they stack up nicely. They're kind of easy to read, and they don't create crazy levels of nesting. So I think that's your next example here, right?
Yep. So this actually is exactly the same as slide 5, but it's a good example of using method level patch decoration. Here where the glance object in this test file is from nova.image import glance, right? So it's a module. It's not a variable in a module. But we're glancing. We are mocking the glance module objects client or glance client wrapper class objects init method. Gosh, that's a heck of a tongue twister to say, but that's what it is. We are mocking the glance module objects glance client wrapper class objects init method. And we are doing the same for both of the test methods here. When you use this method level patch decoration, you'll note that the mock object that is returned by the mock patch object decorator is added as an argument to the test method. So one thing that actually I did not include slides on, but maybe there's an example later on, is a very, very common mistake that people make, which is you have to remember that the order of the mock arguments that get added to a test method for multiple decorations of mock.patch or mock.patch.object are added to the test method's argument list in reverse order. So it goes from bottom to top. Does that make sense?
So bottom
Yeah,
is leftmost.
Yeah, it's a stack, so you just kind of have to read it like last in, first out.
Right. So if
It's
we had two, go ahead, Dan.
no, I'm just saying it's slightly confusing, but you get the you know, if you do it enough, you just kind of get used to the fact that that it goes from
But
top.
it's a very,
just as a
common-
rule of thumb, bottom is left, and as you stack on top, they go into the right parameters. Okay.
Correct.
Cool.
All right. So the next slide is the exact same set of tests that, but using a class level patch decoration. So here, instead of calling mock.patch.object as a decorator for both the methods and repeating that set of code, because we're patching the glance client wrapper init method in the exact same way for each of the test methods in this class, we can use a class level patch decoration like this. Dan and I have, when we talked about this earlier today, we sort of differed as to whether we should encourage this kind of behavior. Well, we don't differ on whether it's useful in some cases or not.
So
Which
is the behavior you find more useful, and which is the one that you find less?
Well, so since I'm the curmudgeon here, the thing I don't like about this, I like that it's 2 lines less of code.
So define which this we're talking about.
The one that's on the screen, the class level one.
Okay.
And it maybe is a little bit more striking if you had 4 of these test methods that all mock out the exact same thing. And there was a review recently where I complained about the reduction in code of mocking it at the class level versus the method level. But the deal is that if I jump into a file that has a class with say 20 of these test methods, and each one of them doesn't have their mock on them, but because the class is mocked, it's harder for me to kind of jump into the middle to fix, adjust, or add a test and know what the state of the world is. So some things were mocked out. I may or may not see them, and I might go to add a test here, and I don't provide an argument because I didn't mock anything out, and that fails because the class decorator is passing it to me. So okay, I add that. It's obscure to me, and we have so many test files that are very large with large classes. It's just I really much prefer to have the things that are mocked out be mocked out in the smallest scope possible, where wherever it makes sense. The good thing about doing this versus mocking something out in setup is that at least I see, okay, this method takes 3 mocks as arguments, so clearly things are getting mocked out. I should go look at it, right? If it's done in setup, like I don't even know that they're mocked, and I'm cursing for 30 minutes, like trying to figure out why the database method or something is returning this crazy data that I don't know about, right? So this is certainly better than the setup approach, but I don't like it because it's obscure and it moves the mocking visibly far away from the actual test code.
Right. In this particular case, I find it okay just because there are only 2 permutations of the get remote image service method, and everything's on a single screen as far as like what you're looking at. But I agree with you that when you get more than just a few methods and it's not immediately obvious where a mock is being created or is coming from, which would be in the case where you're mocking a class level. You're mocking at the class level, but you have to scroll through 5 or 6 screens just to figure out, where where that's coming from, I agree with you that there's a little bit of a balance there. I'm not sure I would go so far as to ban class-level decorators of mock patch object, but I see your point there.
No, the problem is really not when someone adds something like this. It's when it gets, you start adding things to this over time and it gets out of hand. It's hard to undo it. So the really good example is in the Neutron API test code. We've got classes that have a bunch of things that are mocked out for you. They're not actually class-level decorators. They're done in setup. But the problem is...
I want to be clear that you're referring to the Neutron API test code within Nova.
Correct. Yeah. Sorry. And so the problem is that people will go and add a test in the middle of one of these classes, and they're like, well, so much of this hard work is done for me that I definitely want to add to this class, but I don't need these 3 mocks. And so what they'll do is they'll add a test method and then like undo the 3 things that they don't want done, and then in their test method, and that's just madness, right? It gets really confusing about what's mocked and where, and
that kind of gets into the slide 11 stuff, which is sort of patcher. Oh wait.
This one, 12, right?
12, right? Well, yeah. So 12.
So just one more thing on the last, because I think there's sort of like a nugget to summary there, which is that there is a little bit of difference in writing test code versus maybe functional code, and the fact that normalization and optimization are not always the things you're going for, because this code is interesting when it breaks, and you have to understand why it breaks.
Right.
You mean being totally dry in your test code is not as good as it is in your functional code? Is that what you're trying to get at?
Yes.
I totally agree. I really appreciate sometimes where properly exercised, having 2 tests that actually reproduce quite a bit of code to test the same thing, but in the different. It's just much easier than some of these where we have a generic kind of inner method that has a bunch of conditionals in the test, and then we call that with a bunch of different arguments in different ways. And yes, you saved like 20 lines of code, but now it's really complicated. You get this test that mirrors the functional thing that you're testing so much that it's really hard when something changes.
Right, and whoever said it was kind of like an art form, I think maybe it was Matt Booth this morning on the Etherpad, but it really is. I mean, a lot of this stuff there aren't necessarily like black and white answers to certain things, and I think this is one of those areas. I do certainly appreciate more explicit clarity in unit tests, even if that means a little bit of duplication, duplicated code, versus hiding something in certainly a setup or a faked out driver. I think those things tend to obscure unit test code more than help any sort of efficiency or dry principles.
Cool.
So
I just want to
black and white. I think you either agree with me or you don't.
We know that's how Dan thinks. Okay, so I just want to provide a time check too. So we're at like 3:40 right now, so we're like 20 minutes to the top of the hour, and make sure that we hit some of the other topics here, like specs and sentinels and such.
Yeah, and
So
also Brent Knutson has a. I just like saying Knutson.
Okay.
I don't know. Maybe it's just my Big Lebowski fanaticism. But yeah, Brent Knutson has a question from the audience. So.
Oh, do you want to read the question, Jay?
Sure. He says it would be interesting to have an example where someone isn't using mock but should be. For example, and he's continuing as I write, or as I read here. For example, monkey patching with a local function. So just examples where you saw someone not using mock and said, use mock for this. This is an amazing interaction between YouTube, Hangouts, and Etherpad. All right. So most of the time that I actually bitch about people not using mock, it's typically because they're using mocks or stub out for something for new test cases. I've actually kind of gone around the sort of in a, not a circle, but I've evolved my thinking about this in regards to code reviews. I used to be kind of stringent about, has to be mock for anything that's newly added. I've now there's sort of a gradient of whether or not I will -1 something solely because of the use of mocks. And in a lot of the existing legacy, I guess we call legacy test cases or existing test cases, there's use of stub out and mocks based on the base test case class. And I don't just mean nova.test.test case. I mean the base. Some of these unit tests are 5 or 6 levels deep as far as subclassing, and somewhere in setup or a helper method, there's the use of stub out and mocks, MOX, and if you were to use mock for something, you would end up having to write a whole bunch of code that is already done for you in the base class. So I've kind of gone round and round on this, and nowadays I'm just kind of like, yeah, we prefer mock if this, if it's a completely greenfield unit test, I pretty much insist on using mock. But if it's certainly a subclassing an existing one, then you be a little more lenient on it, I guess. I hope that maybe that's not what Brant was actually.
I think he was going for some of the fake object stuff, but maybe we come back to that. I would say, why don't we jump to some of the attributes and spec stuff that's in the slides?
Okay.
Because definitely the specs and Sentinel stuff is stuff that I'm convinced I'm not very familiar with, and I would love to see some explanations there.
Okay. So all right. So the slide I have up is 15. I hope that's what everyone else is looking at. Let me go ahead and if you go to 15 again, Dan.
Yeah, I'm on 15.
He's there. Yep.
Oh, okay. Let me just get a link for this into the. All right.
Hey, we have a link. Yay.
Okay, so this code is. Let me explain the genesis of why this test case even exists. So within Nova, we use the Glance image API for grabbing metadata and disk image block data from backend storage. However, the version 1.0 API public specification for the Glance API is different from the V2 one. It's not backwards compatible really in any way at all. And we were in one of the RBD feature related patch series. We were relying on the Glance API v2 behavior of returning a set of locations for an image, right, in backend storage. And long story short, the way that the code in the Nova image Glance module was checking to see whether an image was available was assuming a version 2 HTTP response from Glance, and if a version 1 API service returned a result, due to the way that it was interacting with the glance client library, it would actually throw an attribute error and a traceback and return that to the caller, which wasn't good. So we added a test into the code that would highlight this problem. And the way to do that was to check for the existence of certain attributes on the image object that was returned by different versions of Glance Client, the version 1 stuff and the version 2 stuff. The way that we went ahead and supplied an object that would be tested is using the mock specifications. And this is how you give it a class object that has the attributes that you expect defined in it. And when you create a mock object using mock.magicMock, if you pass in the spec keyword argument with the name of the class or the class object, and then all of the other keyword arguments are the names of attributes and the values for those attributes, then the mock object that is produced will only allow attribute setting for the attributes that are defined in the specification class. Gosh, that's really a tough way of describing it, but
so how is this
so
better than doing fake objects?
So let me.
Go ahead, Dan.
Oh well, I was just going to kind of explain the subtext here, which Sean asked you a very hard question. So, but the thing is, a magic mock is magic in that it has all properties. Like if you use a property or a method, you call a method on this thing, it just exists, right? And so so if you were to pass a magic mock to something, you would never get an attribute error on that magic mock because it lets you do anything to it basically. Right. And so this constructing it with a spec ensures that it will not do that. So that if you're trying to make sure that the magic mock you're passing to a method only has the attributes of the real thing that would have been passed to it normally, you use the spec thing, right? Otherwise, you'll never have this attribute error issue, right? And so I think what you're doing here in this test is making sure that we're passing a magic mock to this thing, but that has a very concrete behavior of either the V1 object or the V2 object, and making sure that it would
that it doesn't blow up and throw an attribute error, right?
Well, and that the magic mock doesn't hide what would have blown up because the magic mock is very forgiving, right?
Correct. I mean, it's the same reason why. One of the most common mistakes with using a mock object is to call assert called once, which actually isn't a real method of magic mock. Assert called once with is the name of the real method. But because magic mock magically mocks everything that you pass to it, it's very vulnerable to spelling type of mistakes. And using a spec object that defines the attributes and only the attributes that are allowed to be referenced by that object is a good way to avoid those kind of common typo mistakes. And in this case, it's an example of how we used a spec to verify the behavior that the different Glance client version objects were displaying.
All right. So the easy question, then the hard question. So the easy question is, on a magic mock, everything returns true if you call a thing? Like,
well,
the magic
it's truthy. Truthy.
Okay.
Everything does not raise an exception.
Okay. And I guess the hard question is the one I asked before, which is, this seems very close to the entry pattern you were talking about before, where you're testing of an interface that you have artificially constructed that's not actually the functional code.
But that's the reason why you wouldn't. Jay will have to correct me if I'm wrong, but if you just created. No, he is doing that here. Yeah, he's creating an object and then using that as the spec. That's what you're getting at, Sean?
Yes. Versus, like, is there a way to actually, like, say, oh, this object in my functional code, like, that's the spec?
Yeah, so that's what you would normally want to do. I think he's probably doing this here because he's testing a very specific thing that might be hard to do with the current state of the code, but generally that's what spec is for, right? Is that you pass the actual implementation as the spec so that the mock honors the kind of the fingerprint of the real thing. It's just that here he's testing a very, very, very specific scenario.
Okay.
So, a good. I will paste into slide. Which slide was this, by the way?
But while he's pasting, so Sean, the question that you asked initially was why mock it at all instead of using instead of just using fake objects that you created. And I think the answer is not maybe obvious here, but if after you run this, or after after you do the actual call the method that you're testing, you wanted to make sure that some of the things that were valid in the spec were called in a particular way. You still want the mocky behavior, right?
Right.
Yeah, no, mostly about the fact that these objects were synthetic and they weren't like real code, which means you have the interface drift question.
Right. But normally you would pass, I think, the actual implementation as the spec so that you get a mock that matches the actual thing you're testing.
Cool. All right. So I'll give another time check. We're about 5 before the hour. I'm going to assume we're going to run long just so that we do cover things and take some questions, and we knew this is the first time through, so it might be a little long, but we should probably continue jumping to the next chunk here.
Go for it. Mock.sentinel. I love using mock.sentinel. So the reason it's kind of cool is when you don't care about when you don't care about this is really difficult to explain. Let's see.
Well, so a good example of this, I think, is we have a lot of places in the code where we need to call a method that takes a context, and it's never going to get far enough to do something with that context, and so we don't actually go create one of our request context objects and pass it in. We pass in the string context, right? Which is fine, but mock.sentinel is a good way to
avoid having constant strings everywhere.
Well, and it also it's very symbolic, because when you do your assert later, you're asserting, not that it was called with this weird string, but that it was called with this sentinel, right? And it's just very
specific object, right?
Yeah, it just ties it together. I called it with this fake thing, and then I'm checking that the next thing was called with that fake thing as well. I don't care what it is. It doesn't need to be, this weird string.
Right. I don't care what it is. I just want to know that it was that specific thing was passed.
Right.
So this would be the equivalent. Like, this is just, it's just a.
It's foo.
Okay. Like, you could just make an object, like literally an object call here, and it would work. Except that might. I don't know. I guess this
object call.
Well, like literally just object constructor, like arbitrary object.
Yeah. Because that's how we do sentinels in other places, right? Is that you just create a new object, an object, right? And you use that as your sentinel you pass through. Yeah. So BDM could be object open close paren, and that's just your sentinel, right? But this is symbolic, because then later you can refer to it as mock.sentinel.bdm without having to have ever stored it first. You don't need a local variable to remember it later.
And it's
a global. It's a global namespace, effectively. You're allocating these by name in a global namespace.
It's thread local, but yeah.
Yeah, but that's the symbolic nature that I was talking about.
So and the other symbolic part of it is that by using mock.sentinel and then a symbolic name, you're actually describing explicitly that the method call that you're making with that sentinel object is not inspecting or using that object in any way that's important for this test. So it's a way of saying, in this specific case, it's saying we know that self-compute remove volume connection is not calling attributes or methods of mock.sentinel instance object. It's a way of describing that.
And would it throw an exception if it did?
It would, because it would say mock.sentinel inst ob doesn't have an attribute for blah blah blah.
Okay.
And that's a way. It's a way of writing into your unit tests a contract.
It's like the anti-magic mock, right? It is nothing.
Exactly.
Yeah.
It is only this. It's a symbol, and if you use it in any other way other than just passing it to some other thing, then you're going to get an error.
So here's the thing to be careful about with these, especially using Nova objects, is that these will stringify to their name.
Yeah.
So I have gone in the past to create a Nova object of something and then set a bunch of attributes on it to sentinels. And the things that are strings, it will stringify to the name, which isn't so bad, but they won't coerce to an int or anything, or a Boolean. Well, actually, they might to a Boolean, but it kind of breaks down there. So you really,
especially with logging. So. Yeah. If there are log statements that use, for instance, like the instance object, you'll see the stringified version of the sentinel in there, which, if you're doing debugging, can sometimes make things a little difficult.
Well, yeah. So there are times where this doesn't work, where I still have to do, instance.id equals 123, make up a foo value because the type coercion is going to break when it sees this thing that can't become an int, right? And there are other times where you set, some string value and it actually gets stringified to its name. So it's not like a totally inert object. It mostly is, but it will get stringified. So have to be careful with that.
All right. So why don't we got 2 gotcha slides here. We're at 4 o'clock, so why don't we hit the gotchas and then see if we have any further questions from the audience.
So we kind of already covered this, and it goes back to the fact that a magic mock is magic, but make sure that you understand that there is no such method called assert called once. There's a method called assert called with, and a method called assert called once with. DIMS actually just put through, and it's merged already, a patch into Nova's hacking guidelines that prevents and will error out with a hacking violation the most basic checks for this, which is when people call assert called once parens. Other types of typos and stuff like misspelling with or once aren't going to be caught, but still, it's something very common because you got to remember that every method that's not called assert called with and assert called once with is going to be a magic mock method that won't raise an exception.
So anytime I write code and then write a test for it, and the test passes the first time, I'm always highly suspicious that I wrote 2 methods and didn't create an issue at all. And very often I will party early and then realize that I did assert called once, and it's like, sure, fine, test passes, didn't really assert anything.
Right. All right, so gotcha 2?
Gotcha 2.
I believe it was either Matt Wiedemann or Dan Smith that put this into the notes or whatever on the Etherpad under gotchas. And this is the piece of code that they were referring to. So in this, we're we're mocking Oslo DB, SQL Alchemy utils, drop index, and add index. There's two things to note here. So the add index and drop index parameters of the test method, those are actually unused. So utils.dropIndex and utils.addIndex are referring to different things. And of course, it's extremely confusing that this works in the way that it does. But anyway, you always want to know what exactly you're mocking. But this does work the way that you think it'll work, but utils.dropIndex and utils.addIndex are not the same thing as addIndex and dropIndex because of the way that mock mocks things. But anyway, I guess this is a bad example because it actually works, but it's not working in the way that I think the person that wrote it thought it is.
Well, no, but that's a good example too of where you can get yourself spun around. I think Dan just made like a really good insight, which is the fact that that it's really easy to write test code that passes and you think it's the right thing, but until you can see it actually fail when it's supposed to fail, you have no faith that it's actually preventing the behavior that you want. And this is one of those instances where sure it works.
Yeah.
It's not going to fail when you think it's supposed to fail.
Right. So above is if you'd have done mock.patch.object utils, comma, string, drop index, that would the line utils.dropIndex.assert called once with would be referring specifically to.
So the reason that this doesn't, I'm not really, this wasn't me, so I'm not really sure where this code is, but I mean this often works. I think it just depends on how utils is constructed, right?
That's correct, and the order in which certain imports happen.
Right, yeah.
So the reason I thought this was a pretty good example is because it's confusing for the reader. The add index and drop index variables are actually unused, but they are referred to by utils.dropIndex. So you could have left off utils dot and from utils.dropIndex assert called once with and gotten the same behavior.
Yeah.
But it's the reason I say there are different things is because the scope in which the mock applies is different.
Yeah, so don't do this.
So don't do it. That's, I guess what I'm saying is if you're going to do something on utils.changeIndexColumns, then mock out that object. Use mock.patch.object utils, comma, drop index instead of mocking the full module string name.
Okay, cool. All right, so we'll call that the end of the content. Hey Dan, you want to unshare so we actually get your camera?
No.
Also, Jay, I think you have to flip your camera off and on again because you're frozen on my view at least.
Oh, I've got his video.
Do you? Oh,
Yeah.
I didn't. Say something, Jay.
Say something, Jay.
Okay, great. Okay, so that was good. This is first time through. We're a little bit longer than we were planning originally, but I think that's fine. For anyone still watching at home, we had Brant's question, but I don't know that we've got any other questions there. So now would be the time to throw something in the Etherpad if you wanted to ask a question of our gracious hosts. Otherwise, Jay or Dan, you guys have any sort of last summary words on, do this thing, don't do this thing?
Well, I actually could comment on what I thought he was asking initially.
Who is he?
Brant.
Okay.
So there are, and this actually goes to a piece that we skipped because Sean was being the taskmaster and Jay was being long-winded, but one of the things that's nice about mock when you use the decorators or the context managers is that the unmocking of the thing is done for you. And sometimes when the patchers are used directly, like if you see things being mocked out in setup or stubbed out in those cases, you have to be careful to make sure that you unmock the thing when you're done, right? Because later tests are going to run and expect that thing to be different. And so I guess what I thought maybe Brant was getting at is that there are some really old tests that we have that just like flat out, like grab the current value of something, set it to their own function, run their test, and then set it back to the original thing when they're done. Really, really dangerous because then that thing is still mocked out or broken later if you don't unmock it or reset it properly. So we had an example of that recently where it was in the PCI code where we were using a patcher directly in setup, and then we typoed the add cleanup line, which was going to unmock it at the end of the class, right? And then like 5 minutes later in the unit test, some other thing broke that was way far away from anything that we had touched, and it was because that mock never got unset, right? So, so there are cases where using
12, actually.
What's that?
It's on slide 12.
Okay.
For those following along at home.
Yeah. Well, anyway, the point is the decorators and the context managers are really nice because they won't allow you to leave your test with the thing still mocked. And that's why adding the patchers directly is really dangerous. And what I thought Brant was maybe getting at, which is just flat out uncool monkey patching of things.
Cool. Jay, any last words or thoughts?
No. I just would.
Jay's had enough thoughts.
I would just echo what Dan said about being very careful about putting stuff in setup that has to do with mock.
Cool. All right. Well, I'm going to thank you guys for joining us today. Thank everyone that watched in. We've got 17 folks still on the stream. People are starting to drop now. I'll hit stop here in a second. This will be up on YouTube for archive, so feel free to go and check it out wherever you want. We'll share the link. Thanks, everyone. We will see you at some yet unspecified time and date in the future, but we're going to be doing this a bunch.
Ciao.
All right. Bye.